Hi everyone, my name is Kingsley and welcome back to the video on the continuation of clustering the Juniper SRX devices. Now before we continue, we need to do a little recap of what we have done so far and then what is left for us to implement. Okay, so let me grab my pen. So we've set up the control link, right? And yeah, from here we got our management, right? Remember, each device has its own management IPs. We tested SSH from the switch to those IPs. It worked pretty well. And we also set up the fabric link. Okay. Now the fabric link is for, ROTOs, replications, and also sometimes you can pass production data traffic. Okay. Then we also set up the RETH interfaces. Okay, so for the one link, we assign it to RETH interface 1. Okay, for the LAN connection, we assign it to RETH interface 0. Right? So everything is set up now. So what is left? Well, what is left is not really related to clustering. It's the basic things you do on SRX devices. We need to talk about security. Okay. So we need to create zones. Right. Now for the zones, you're going to have the trust and the untrust. Right. The trust, of course, is we tie it to the LAN connection, which is your RETH 0, while the untrust part will be the wide area network. As in, those are basic things you do on any firewall. Then we're also going to create policies. Now, policies determines policies are used to determine how traffic flow between zones. Okay, so if you have the trust to untrust, right, and also from the untrust to the trust. Okay, we need to define what is allowed between the zones. That's where policy comes in. You create the zones. You can also determine what is even allowed into the zones, because we need to say, okay, if there's an IP, an interface in this zone, can you ping the interface? Can you allow certain protocols? Can you allow certain services? So we need to create that. Those are basic things you do if you're already familiar with SRX. You know, these things are there. So this is what we need. This is our focus for this video, because we are done with this part. Direct interfaces, we've already given them IP addresses and everything is fine. So the security part is what we need to fix. And then within the security too, we need to talk about, so now for these servers, for them to be able to reach the internet, so here is 8.8.8, which is what we test with. There has to be network address translation. So part of the security, under the security zone as well, we need to implement NAT, network address translation, which is, just basic thing. Okay, so we do Source NAT. Okay, we'll say if IP is coming from this subnet, we want to NAT it to the one interface IP, which in this case is this, right, at this level. Okay, so we just, that's what we need to really, what is left for this part. Then the next section, that is when we will definitely begin our testing. We'll do our failover testing, look at the different methods we can initiate failovers. We can do monitoring of the interfaces. We can have manual failovers. We can have, when there's a hardware failover, we can have a situation where a port goes down. So we have to enable port monitoring. We also need to do IP monitoring, things similar to IP tracking. So we can be tracking like Google DNS IP on the internet. When it becomes unreachable, then we're going to initiate failover. So that is what we'll do on the next video. But for this, we just want to fix the security and ensure the servers can reach the internet. Okay. Now, before we begin, we need to make some little changes in our if design. So now, if it's virtualized environment, and there's a whole lot of things that happens that is not really that is binary to us, right? So if you look at this port, what we have is we have port 0, 1, 2, 3 to 4. Okay, so basically we're already using 5 ports here. Now I have to be honest, I already made this video, but I ran into issues. The issue was the RETH interface refused to come up, right? It's not that I refused to come up, I could not ping. I had an IP assigned to the RETH interface, but I was never able to ping it from the LAN or from even the switch. Okay, now the issue is I don't know. What I know is that we have 5 ports here, right? And we have 5 ports here, and yes, the actual port 4, which is the GE7/0/0/4, is actually connected, right? But we could not ping. So what I did was that I came back and I added GE/0/0/5. Okay, I added it to both sides, right? So 0/0/5. And the moment I added it and I rebooted my devices, it was working. So it was more like the GE0, it means the GE0/0/4 we're actually seeing here, right, is actually maybe 3. I don't know. Okay, it's just the if thing. Maybe the if expert can explain, or Juniper themselves. But what I did was just to add that interface. So we're just going to do that now. Okay, so it means, so something else I did to actually know that that port wasn't connected is that I enable LLDP on the 2 firewalls. Okay, so I enable LLDP both on the firewall and on the switch, right? And for the life of me, I never saw port 4. I never saw this port GE0/0/4, or which is the RETH interface. RETH interface 0, I think, right? It never came up, and we didn't say what only showed up was the RETH 1, and of course your management and your fabric link. This showed up, but I never saw RETH 0. So I spent a lot of time, almost 15 minutes, trying to figure out what was wrong. I later found out it was this that was missing. So I decided to delete the video because I mean it was just too long and not necessary. Okay, because it wasn't a config issue, it was actually just the if thing. So I'm just going to take that connection now and say for port 5 is going to go to port 16, right? And here the same thing, port 5 is going to go to port 17. So that this port actually represents the LAN interface, I mean. So let's power up. I'm going to power up these devices. I'll pause the video a little bit so that we don't spend too much time waiting. So I'm going to power them up. It's up now, so I'm just going to pause the video. Once it's back up, then we can continue. So the reason I decided to show you this, I know there could be a lot of folks that are following the setup, so I don't want to skip any part, and mine is working, yours is not working, that kind of thing. So see you once the devices are up. So the devices are up now. So I'm just going to log in, and then we can begin configuration. Okay, so same for the secondary. Let's go 1, 2, 3. So this is the secondary. So if I show chassis cluster status, I believe as I still booting up, the processes are still coming up, but we don't want to waste time while the device is still trying to fully boot up and enable all the specific features and processes. We need to focus on the security part, right? So we need to create 2 zones, right? So we're just going to security. So edit security, right? So we create 2 zones, the trust and untrust. Trust is for the LAN, while untrust is for the WAN connection. So that's what we need to do. So we can just say now that, so we can say set zones. Okay, security zones. So we create a trust zone and we say the interface here is the RETH1, RETH0, right? And then we can say, what are we going to allow? We can say system, I think. Okay, so we need to go through that part, and then we need to say host inbound traffic. That is what is allowed to that zone. We're going to say for system services, we just want to allow everything. This is a lab environment. And then we're also going to say for protocol, we also want to allow everything. Okay, that's for the trust interface. So we also need to do the same for so set zone. So we're going to say this time is set zone, security zone. So we're going to say this is the on trust interface, right? And we're going to say interface RETH1. Okay, it's going to be the on trust part. That's the one interface, remember? And then we're going to say for the system, what do we want to allow? So we need to say host inbound traffic. So we need to say protocol or then system services or okay. So if you do show pipe compare, right, so that's what you have. So we have two zones. Okay, I still need to explain. So we have our zones. So we have the trust zone, and then we have the untrust zone, and then we align all system services. We also align all protocols, and then we are tying RETH1 to that interface. Same for the trust zone. I think it's very clear. So we can say commit check. Let me grab my pen. So we can say commit check. I say can only commit on the, okay, so we need to go to the top and say commit checks. It should succeed. The config should be, the config is straightforward. Error code, SSM error code this. I'm sure this is just it's not related. So let's just commit. Okay, we still keep getting that error, SSCM lib error code invalid. I'm really not sure what this is. It could be, it's not related to what we are doing, I think. But let's even see, let's say show chassis cluster status. Show chassis cluster status. Oh, so we need to go to show chassis cluster status. Yeah, so it's still, the processes are basically still trying to come up, right? I think that's, they've not fully synchronized, because if they are fully synchronized, this part will turn to none. I think that's really what it's saying. If you say show chassis cluster interfaces, so you can see even the right interfaces, everything is still down. So we need to still give it some time. But let's also create a policies. So edit security, and then we're going to say set policies, right? From trust, you say from trust to untrust. So for traffic going from the DC to the internet, we're just going to call it trust to untrust. Okay, policy. To untrust, okay, policy. So you need to specify the policy here. Okay, and then what we want to do, we're going to say match application any. So we align all applications. We're going to say source. Now there are different options there, okay, but what I'm just going to say is source address. We're going to say any, and we're also going to say match destination address. We're also going to say any. Okay, so show pipe compare. That's what you have, and then we're saying if it matches everything, then we want to, if it matches these parameters, we want to what permit. So let's also create the other policy for the reverse. So this time from the on trust to the trust. So we're going to say set policy on trust from zone on trust to zone trust. Okay, and then we're going to say policy, we're going to say on trust to trust. Okay, then policy, and then we can say match. So we're just still going to allow everything. Match application any, match source address any. So you can say just allow CMP or TCP port this and that. So the next one is match destination address any. So here we're just aligning everything. Okay. Then we're going to say once that is allowed, then we want to say then permits. Okay. Show pipe compare. So that's the policy. So we have the zones which we've configured to allow, we define what is allowed to the different zones, and now we're also saying what is allowed between the zones. So traffic from different zones that try to communicate what should be allowed. Okay, now if you don't want to do this, there's a default command, I think it's set policy, right? It's called default policy, right? And then sorry, I'm just saying if you don't want to create these zones, you just want to allow everything, this command is set policies default policy, I think it's permit all. So if I do question mark, you have the permit all. So if you enable this, then we don't really need all this. Okay, so it automatically just allow everything between the zones. Okay, maybe for testing or troubleshooting you can do this. Okay, so we can say commit check, go to the top, commit check. Okay, so and commit and quit. So let's go back and check if our devices are fully up and running now. Show chassis cluster status. It seems it's still not done. And let's say interfaces. Yeah, so I think all our interfaces are up except for Fabric 0. Why is this still down? I'm not sure. We could just give it some time, but at least we know our control Fabric link is down basically, and our control link is up, and RETH interfaces are up. So let's keep doing what we have to do. Now the next thing is we need to implement NAT, network address translation, right, for the traffic coming from the LAN. Okay, so we just need to do that. So it's under the also edit security. So send NAT, source NAT is what we need to do, and then we can say rule set. We're just going to call it global NAT rule. Okay, and then we need to define the zone. Say from zone trust to, so from zone trust, then you need to come and say to zone on trust. Okay, so you're saying if it's coming from the LAN out, and then you now need to define what you need to match. So rule, then we need to say rule, and then we just call it rule 1. Okay, and then we say match source address, right? Now the source address in this case is is the 10.0.0/24, right? Okay, and the destination is in the internet, which is really destination address is the 0.0.0/0. Okay, and then we can say So if it's coming from the 10.0.0 this /24 subnet and it's going to the internet, what do we want to do? We want to, we can say then, I think, then we need to say source NAT. Okay, we want to say source NAT to the interface, which is the one interface. Okay, so we can go to the top and say show pipe compare. All right, so if you've not configured NAT before on the Juniper devices, this, I think NAT is a whole topic on its own, because you have source NAT, destination NAT, and you know, a lot of different NAT implementations for Juniper. So here we are saying we are doing source NAT, right? We give it a rule name, and then we say if it's coming from the trust to the untrust zone. Okay, and then we say if it matches this subnet, then and the destination is anywhere, then we want to NAT it to the physical interface. It's pretty straightforward. In Cisco, I think this is just like a single line. Here, so another options we could do here, instead of NATing to the public interface, we could have said create a pool. Okay, I mean, just similar to what you do in Cisco. Okay, so here, Juniper is a different word entirely. Okay, so we can commit this, commit and quit. So it's applying it to node 0, and then it's going to apply it to node 1. Let's check our cluster again. Show chassis cluster status. Still not up. I hope my switches is up. So let's go back to the topology. Yeah, everything seems running. And can I ping the internet from here? That's my gateway. It's pingable. Ping to 8.8.8, right? So I mean, so let's do show routes. So everything seems in order except the clustering that is not yet fully up. So we have our, this is the LAN connection, RETH 0. This is the WAN connection, RETH 1. This is the management for FXP0 for this device. And then, of course, this is like the local IP for the WAN interface. So, okay, so let's go back to our topology. So we need to do some tests from these servers now. At least we should be able to ping the gateway of the primary. Okay, and so these servers, I believe I've already given them IP, I'm not sure. So let's say GNS3. So most likely the IPs are not there, so let's fix that. Sudo ifconfig ethernet 0. I will not make the same mistake again now. 10.0.0.20, and the net mask is 255.255.0. Now for this device, there's a way to make the IP permanent. You need to run a script. Sudo route add default gateway, and it's going to be 10.0.0.254. Okay, so ifconfig, the IP is there. Can I ping myself? Yes. Can I ping the gateway? Ooh. You should be able to ping the gateway, right? Yeah. Yeah, you should be able to ping the gateway. It has to work, you know. It has to work. So let's do the same thing for the second device. Let's check what the IP is. 10.10, right? So let's fix that. GNS3, sudo ifconfig ethernet 0, and the IP is 10.0.0.10, and the net mask is 255.255.0, and we can say sudo route add default gateway should be 10.0.0.254 ifconfig. So we should be able to ping the gateway now. Yeah, it should work. Nice. And then we should also be able to ping the internet. Interesting. Okay, so here I believe the command is show flows, it should be show security flow sections. Okay, it should tell us yes, that the different sessions that are currently going on the device. So this is the session ID, this is the policy, and it says if it's coming from, it's an inbound from this IP. I'm not sure what this but of course we know this IP, right? Our IP, I don't think this is related to what we just did. Yeah, so this is what we're interested in. Okay, so this is the session ID, this is the policy name, self traffic, and then it says if it's coming from 10.00.20 on this port, hitting the gateway, and then the gateway responded. So this is the ping between the server and the host. Let's look for the one that goes to the internet. Yeah, so this is, it's coming from this server, destination is the Google DNS, and then from there it goes out to 1.30. So this is the sessions. This is just session. I don't think this is related to NAT. So I think so. We can also say show security NAT. Let's see the options we have here. Let's say interface NAT ports. Okay, so I think this is telling us the how many. This is so you have your NAT single port allocated. So I think so here we have 5 for single port allocated. So the number of allocated ports for that has been allocated for NATing, I believe that's what that means. Let's also see what other options we have. Let's say resource usage, resource usage. Let's see what we have there. Question mark. So we're not doing source pool, so we don't need that. Destination source, let's say source, and then summary. Let's see if summary gives us anything. Okay, so what this is saying is total pool. There's no pool really because we're doing source NAT. So it's coming from source to on source. So I think the one that gives us the best information is this flow sessions. Okay, if you go down, we actually see those traffic that goes out to the internet. But what I wanted to see is the translated IP. Is the ping still going through? It's still running. So this is 10. I think it's coming from 10.10.10. Let's see. Can we see last? Yeah. So these are the last ones. I think this is the most. This is the session really. Okay. It's coming from 10.10 on this source port, going to this Google on this port, right? And then so you can see that the incoming, this is the, so this is in, right, from the RETH0 from the LAN interface, and this is outgoing. Okay, outgoing destination IP is this, destination source, destination port is this, and so it's going out with this IP, okay, on this port, okay, because we are NATing it to, we're actually doing the network address transition to this IP, okay. It's really not as clear as you will see it in Cisco, I think, because if it, oh, maybe it's the same, because you see here it tells us the protocol that is actually ICMP. Yeah, so if we also do the same thing from server 1, I believe it should, so we can say ping, we can say 4.2.2.2, So we're able to ping 4.2.2. And so if you come here and say last, it should also show up there now. Okay, so we also have the same, that the outgoing is being NATed to this IP. So this is the source that is coming with this port number. Once it's translated, it's more like your port address translation, you know, with Cisco. Okay, so we know the servers can reach the internet, but let's say show chassis cluster status. Yeah, I think everything is fully synchronized now. Okay, so everything is fully synchronized, and if you say show chassis cluster interfaces, yeah, we're good. Okay, so our fabric links are back up, our RETH interfaces are up, our management control interface is up. And now, so one thing we can try is we can just initiate a failover. Now we need to have a dedicated video for, you know, testing failovers and how we can trigger failovers. We can do manual, but what I'm just going to do here is the manual failover. I'm going to say, so you know this is the secondary, right? So we're going to do a failover and we're going to see what is the impact on the devices. We shouldn't see, we are not supposed to, we are not expected to see any packet drop when we do a failover. So I'm going to say request chassis cluster failover, right? Nodes. So you need to specify for which redundancy group. So we're going to say redundancy group 0, which is the control plane, and then we're going to say fail it over to node 1. Okay, so we do that. You say initiating failover. Now if you go back and say status, see what happens. Now when you initiate a manual failover, you see it automatically set the priority for the group to what? 255. Now this value is going to remain here this way, right? In the next video, we're going to talk about preempts. We're going to talk about the different ways we can actually do failovers and how we can do monitoring. But what we just did now was that we initiated a manual failover for the redundancy group 0. But don't forget, see, redundancy group 1, which is actually the production traffic, still goes to where? The node 0, okay? And we did not see any drop. Was there a drop? No, so there was no drop. Okay, if we come here as well. So when we fail over the control plane, there was no drop. Let's also fail over the redundancy group 1, which is the actual meat of this. So we did it on the secondary. So let's go back and say we now want to fail over redundancy group 1 to node 1. So it's going to initiate that, and if we also check the status now, you see it automatically set the priority to 255. Remember what was the old value? The old value was 100, but because we forced the failover, it automatically set itself with a higher priority. So what that means is the traffic automatically moved to the secondary. Was there any drop? Oh, okay. This problem. Let's see if it's going to recover. Because what we just did now, we failed over to the secondary. Now, in the real world, this should actually work. Okay, it should work, but this is a virtualized environment. Okay, and you might not have as close as possible to what you have in the real world. But from what I see here now, it looks like the secondary is not forwarding the traffic, right? So let's see. The traffic is not going through, or maybe it's still baking. I don't know. Let's see. You see here it's saying secondary on hold here, right? So the control plane, it has not fully converged to the secondary device. Okay, so I'm just going to leave this video here, and in the next session we're actually going to come back and look at why the traffic failed to fail over to the secondary device. It should fail over. Okay, now there could be a lot of reasons. Because we're in a virtual environment, these things do not really work as they should be. and I'm quite sure it's not related to our configuration, because everything we did is straightforward. We have not enabled LACP, we have not done SO. Okay, so we're just going to come back to it in the next video, and then we look at it deeply if there's something we are doing wrong. So in the next video we'll talk about monitoring, specifically how to do failovers, how we can monitor with IPs, how we can monitor with physical interfaces. And I see you back. Now before I go, let's just try to see if we can feed back to the primary and see if so I'm going to say request chassis cluster failover, right? Redundancy group 0, we want to failover back to nodes, right? Before the customer calls and say, oh, my traffic is down. So you need to do a reset first. So he said it's under manual failover already, so we need to do a reset. So let's see if we can do a reset here. I think you need to just say reset here, reset redundancy group 0, and so we do a reset, and then we can also do a reset for redundancy group 1, and then we can initiate the failover back to node 0. So it's still not permitted because everything. So let's just keep it, leave everything to the next video. Okay, thanks guys. Okay, you can see the traffic is back. Okay, so something is wrong somewhere. So let's see, show chassis cluster status. So node 0 is still in the secondary, but node 1 is up. So I believe it's just the virtual environment that is making it seem that it's not working. Okay, but we'll see that. Thank you. So if you like this video, please subscribe and share with your friends. And also when you subscribe, when we make new videos, you get to see them, and then you're able to follow through like this and have hands-on on this implementations from different vendors. Thank you and bye.